Welcome back to Science Corner. Ready for another deep dive into everyday science?
Absolutely.
Today we're tackling a breakfast staple, but one that's more complex than it seems.
Ooh, sounds intriguing.
Toasting bread.
Okay.
We've got some great sources ready to dissect, including excerpts from Wikipedia on the Maillard reaction and toasters, plus a piece specifically on the physics and chemistry of toast.
Wow, this is going to be interesting.
Get ready to learn about how your toaster transforms plain bread into that golden brown, crispy goodness.
I'm ready.
So, most people think toasting is just about, like, browning the bread, right?
Yeah, you just stick it in and it comes out brown and crispy.
But there's some really fascinating chemical reactions at play beyond simple burning.
So there's more to it than meets the eye.
A lot more. Our sources point to the Maillard reaction as a key player.
Maillard reaction, I've heard of that.
Can you break that down for us?
Well, the Maillard reaction, it's basically a chemical reaction between amino acids and reducing sugars. That occurs in bread when you heat it up. It happens at temperatures around 140 to 165 degrees Celsius, so that's like 280 to 330 Fahrenheit.
Got it.
And this reaction, it's responsible for not only the toasted flavor, but also the aroma.
Ah, so that delicious smell is the Maillard reaction in action.
Exactly. And it also produces melanoidins.
Melanoidins, what are those?
These are the compounds that give brown food, like toast, its distinctive color.
So that beautiful golden brown color we love is thanks to melanoidins.
Yes. And the really cool thing about the Maillard reaction is that it's not just in toast, it's actually happening in other foods too, like seared steaks, fried dumplings, even coffee and chocolate.
Wow. So many of our favorite foods owe their flavor and color to this one reaction.
It's true. The Maillard reaction is a culinary powerhouse.
Yeah.
And speaking of browning, there's another process that comes into play during toasting, caramelization.
Caramelization, right. So is that like a separate thing from the Maillard reaction?
Yeah, it's a separate process. And it happens at an even higher temperature, around 180 degrees Celsius or about 356 Fahrenheit.
Oh, so even hotter than the Maillard reaction.
Yeah, it's essentially the pyrolysis of sugar. So basically, you're breaking down sugar molecules, and that creates these different flavors and colors.
Okay, so both the Maillard reaction and caramelization contribute to the browning of the toast. I'm starting to see how complex this seemingly simple process really is.
Me too.
But let's take a step back for a second.
Sure.
How do we even get to these temperatures in the first place?
It's the magic of the toaster, right?
Right, the unsung hero of breakfast.
Absolutely.
But how does a toaster actually turn electricity into heat? I mean, we all use them, but do we really understand the science behind them?
Well, it all starts with something called resistive heating. The toaster basically converts electrical energy into heat energy through this process.
Resistive heating. Can you elaborate on that a bit more?
Sure. It's all based on Joule's law, which states that the power or the heat generated is proportional to the square of the current flowing through a conductor.
Okay.
And the resistance of that conductor.
Joule's law.
Yeah, that's the principle behind it.
So the more resistance a material has to electricity, the more heat it generates.
Exactly. And that's where the heating element in the toaster comes in.
Which brings us to
Nichrome. That's the material commonly used for toaster heating elements.
Nichrome. Why Nichrome?
Well, nichrome is an alloy of nickel and chromium, and it has some pretty special properties that make it perfect for the job.
Like what?
Well, for starters, it has really high resistivity.
So it puts up a good fight against the flow of electricity.
Exactly. And that means it generates a lot of heat. Plus, it's incredibly resistant to oxidation at high temperatures.
So it doesn't rust or corrode easily when it gets hot.
Right. That's why your toaster heating elements can withstand those high temperatures without falling apart.
Makes sense. And I've always been curious, why do those heating elements glow that red-orange color when they get hot?
That's a great question. And it's all thanks to a phenomenon called black body radiation.
Black body radiation. It sounds kind of ominous.
It's not scary, I promise. It's a really cool concept. Every object in the universe emits electromagnetic radiation based on its temperature.
So we're all emitting radiation right now.
Yeah, but don't worry, it's not harmful at these temperatures.
Okay, good to know.
So as an object gets hotter, the wavelength of that radiation gets shorter.
So the hotter the object, the shorter the wavelength of the radiation it emits.
Exactly. And when the toaster heating element gets really hot, the wavelength of the radiation it emits shifts into the visible spectrum.
And we see that as a red-orange glow.
You got it. And there's actually a law that describes this relationship between temperature and wavelength.
You mean?
Wien's displacement law.
Okay, maybe we can save the specifics of that law for another deep dive.
Sounds good to me. We've covered a lot already.
We have. So We've talked about the chemistry behind the browning and flavor of toast, the physics behind how the toaster heats up. But what actually happens to the bread itself during the toasting process?
Well, that's where things get really interesting. Well, the heat from the toaster, it causes the moisture inside the bread to evaporate.
Ah.
And that's why toast is, it's drier and crispier than regular bread.
So like that satisfying crunch,
Yeah.
that's the sound of dried out bread.
It is.
I never really thought about it that way.
And, as that moisture is evaporating, the starches in the bread, they start to gelatinize.
Gelatinize. What does that even mean?
Okay, so think of it like this. The heat, it causes the starch molecules to absorb water, and then they kind of swell up.
Okay.
And so that creates this sort of gel-like structure, which contributes to, the overall texture of the toast.
That's really fascinating. So we've got moisture evaporating, starches gelatinizing.
Yeah.
What else is going on inside that piece of bread?
Well, remember those chemical reactions that we were talking about earlier?
You mean like...
The Maillard reaction and caramelization?
Right.
Those are in full swing now, creating those delicious flavors and that beautiful golden brown color.
So it's like this symphony of chemical and physical changes all happening at once.
It really is, yeah.
Amazing. It makes you wonder how people ever figured out how to make toast in the first place.
I know, right? Toasting has actually been around for centuries.
Really?
Yeah. So our Wikipedia source on toasters mentions that, before electricity, people used to toast bread over open fires.
Wow.
They would use these long-handled forks or metal frames.
Wow. That sounds like a lot more work than just popping bread into a toaster.
It definitely was.
Yeah.
And even when the first electric toasters were invented, they were pretty basic.
Oh, really?
Yeah, they could only toast one side of the bread at a time, so you had to manually flip it to get both sides toasted.
Oh, wow.
Can you imagine having to do that every morning?
Talk about a time-consuming breakfast.
Yeah, exactly. But thankfully, toaster technology has come a long way since then.
For sure.
Yeah, in the early 1900s, inventors started coming up with ways to, automate the toasting process.
So that led to the invention of, the pop-up toaster.
Exactly.
Yeah.
In 1921, Charles Stripe, he patented a toaster that would automatically eject the toast when it was done.
Oh, nice.
It was a game changer.
Yeah, no more burnt fingers from trying to retrieve hot toast.
Exactly.
I can see why that invention caught on.
Absolutely. But those early pop-up toasters, they still only toasted one side at a time.
Oh, so you still had to flip it.
Yeah, you still had to flip it. It wasn't until 1925 that a company called Waters Genter introduced the Toastmaster.
Toastmaster.
Which was the first automatic pop-up toaster that could brown bread on both sides simultaneously.
Wow.
It even had a timer.
That must have been like a breakfast revolution.
I know, right?
So from fireside toasting to timed double-sided toasting.
Yeah.
It's amazing to see how far we've come.
Yeah, it really is.
And the innovation hasn't stopped there. We've got toasters now with all sorts of features.
Yeah.
Automatic lowering and raising, color sensors to ensure perfect browning, even settings for different types of bread.
It's true. Some toasters these days are practically mini computers,
Yeah, they can connect to the internet, display the weather forecast. It's mind-blowing.
I know, but, amidst all this technological advancement, it's important to remember the fundamental science that makes it all possible.
Right. It's easy to take toast for granted. But there's this whole world of physics and chemistry happening in every slice.
You're absolutely right.
It's funny. I've always wondered,
Yeah.
have you ever wondered why buttered toast always seems to land butter side down?
Oh, it's a classic conundrum.
Right.
But it's not just bad luck. There's actually a scientific explanation for it.
Well, tell me more.
Well, it has to do with, the height of a typical table.
Okay.
And the size and shape of a piece of toast.
Yep.
When toast falls, it doesn't have enough time to make a full rotation before it hits the floor.
So it's more likely to land butter side down just because of the way it falls.
Yeah.
It's all physics.
It is. It's a combination of gravity, air resistance, and, the toast's center of gravity.
Wow, I never knew there was so much science behind a falling piece of toast.
Right. But, even though buttered toast might have this tendency for disaster, that doesn't make it any less delicious.
Very true. And hey, it's a good reminder that even with all the science we know, there's still a bit of mystery and fun in the everyday world.
Absolutely. And that's what makes, exploring science so fascinating. It's about understanding the hows and the whys of everything around us.
Right.
From the universe to a slice of toast.
Well said. So next time you're enjoying a perfectly golden brown piece of toast,
Yeah.
take a moment to think about all the incredible science that went into creating it.
It really is amazing.
Yeah.
It's a reminder that science is everywhere, even in our kitchens.
Right.
And who knows, maybe this deep dive has sparked your curiosity to explore the science behind other everyday things.
I know, I'm definitely looking at my breakfast differently now.
Yeah, me too.
Well, thanks for joining us on Science Corner.
It was my pleasure.
We'll see you next time for another deep dive into the science of the everyday.